Add, subtract, multiply. No questions? We have 5 root 5 minus 2 times root 5 minus 1. Ready? Y'all ready? What is 5 square root 5 times square root 5? 25. That's exactly right. Minus 5 root 5 minus 2 root 5 plus 2. Who didn't get their donut?
Wait, but what about the 5?
What about what?
What about the 5 that comes up?
Well, 5 square root of 5 times the square root of 5 would be 5 times the square root of 25, which would be 5 times 5, which would be 25 and 2 gives me 27. Negative 5 root 5 minus 2 root 5 gives me negative 7 root 5. Yes. Yes. Number 11. I have 10 plus 3 root 7. 10. Y'all are throwing this donut around. All right. Here we go. 10 times 10 is minus 30 root 7. Why'd y'all say no? Minus 9 times 7, right? Which is 63. The middles cancel, so I have 100 minus 63, which is 37. It's subtracted and multiplied, and so today, I'm sure you have figured that what's left is division. It's not. It's not. But we've really done it with square roots. We're just adding other roots in here, so it's not as bad. All right, so we're going to work, to start with, we're going to work on that rule that tells us if you're dividing something and they have the same root here. So whatever this may be, I can put them under the same radical this way. So I go backwards or forwards. We've gone more this way in the past. Now we're going to kind of go this way. Yeah. For Miro board? Are you sure you went to the right one? There's no way. Now, do you know I don't have you using any inappropriate websites? Oh my God. Okay, I was gonna say, I have trouble believing that because it was. All right. So, oh my great day. Y'all have hurt Wyatt's feelings today. I need y'all to leave Wyatt alone. A constant, a number without a variable. No variable.
What's the variable?
Yeah. term that has a variable.
What?
All right. For example,
No, go back home.
oh, great googly moogly. Good gracious. Good grief. Holy cow. I'm happy. All right. Let's say I have 12 root 160 over 2 times the square root of 5, and I need to simplify this.
Times the top and the bottom.
Before even doing that, I can do something. How? Well, first of all, 12 and 2 can be reduced to what? 6 and 1. Why don't I just do this since 5 goes in evenly? Then I wouldn't do that. But since I recognize that it went in evenly. Now, if you let me finish this way, and then I'll show you if you've done what Wyatt said first. What? Bigger. 16 and 2. So I got 6, 16 and 2, which is of course 4. So I got 24 root 2. I do need a plus or minus since it's a square root. Now, all right. So let's say I had gotten to this first problem and I did what Wyatt said and I went, okay, square root of 5, square root of 5. Will it still work? Yes, it will still work. Square root of 5 times square root of 5 is what? 5. All right, 160 times 5, I don't know. 0, 0, 800. Is it? 0, 30, carrier 3, 800. Yes, it is. Thank you. Now, square root of 800, how does that break up? I mean, 800. Yeah, 800. 108, but bigger. 400. 402. Right? I'm showing you, this is not the way I would have gone about this problem, but had you gone about it this way, it still would have come out to the same thing. So I got 22 over 10. This is 240 root 2 over 10. Both divided by 10 would give you 24 root 2, and I'm back to what I got my way. I say my way's easier. Yeah. Okay, I don't either. But I'm just letting you know, you can't always do that. But if the situation, but I'm just showing you, if you didn't recognize that you could do it and you went the wrong way, you'd still come back to the right. Okay. Huh? You want a word problem? You want me to make y'all a project?
No, why do we learn this stuff?
You're supposed to learn that in high school 101. Okay. I use this every day.
You're a math teacher.
Like, logically, how much of us are going to be not one. Right.
Probably
I
like
hate to tell you, it's not for me.
All right, simplify.
7. Wait, we can leave the bottom one the same. It goes in evenly, Miss.
What doesn't evenly? Everything actually goes in evenly. I can divide 36 and 9. I can also divide 1250 and 2. Be very careful because I want to make sure that these roots are exactly the same before I combine it. But I can. So 36 divided by 9 is 4. I'm still under a fourth root. What's 1250 divided by 2? 625, which happens to be a perfect fourth root. What is it? So it's 20. Huh? Yeah. Couldn't do it. You'd have to leave it. Have to leave it. All right, one more. If you can do this one on your own, I'll move on.
Nobody put plus or minus.
I did. Anna, come on, guys.
Anna Martin.
All right, here you go. Mark, say go. To the fifth, 3 goes into 5. How many times? 1. And how many are left? Welcome. This one's a little bit harder. Huh? This one's all under one radical instead of being split up to start with, and there's really not anything I can do to simplify before I start. So I'm going to have to take that root to everything and then see if I can simplify some, right? Okay, so tell me what you're going to do. Because I'm multiplying and dividing, this only works because I'm multiplying and dividing. This cubed root goes to everything. So what's the cubed root of 7? Nothing. It's just the cubed root of 7, right? How about the cubed root of 5? Well, 3 goes into 5 how many times? Once. And how many are left? 2. Right? Now let's look at the bottom. Cubed root of 64. And then 3 goes into 6. Indeed. How about that one? Two, 4, 8, 16. 2, 4th root. It's not just 2. 2 to the 4th is 2, 4, 8, 16. So 2, 4th root 2, W. That's correct. That's the answer. Now the problem comes in, what if I start doing this and I end up with something like, you're good there? Let's say I work to simplify and I get down to something like this. What's the problem?
Radical.
Can't have a radical in the bottom, right? So how do I get rid of a radical in the bottom? I do what's called, do you remember what it's called?
Rationalizing denominators.
We have to rationalize the denominator, right? So we have to get rid of. So here's what we do, because we're going to get into some pretty complicated rationalization. So stay with me. You want to make sure you get the easy so you can get the hard part. All right. If I have just a radical in the bottom, okay? So I'm a fidgeter. Sorry. If I have a monomial denominator, what does monomial mean? Denominator. I'm going to multiply the top and bottom by the radical in the bottom. That's kind of wordy. By the radical that's in the bottom. I don't need to multiply by 2 root 5. I only need to multiply by root 5 top and bottom. Okay? And then I can simplify from there. So I need everybody to see the difference, that this is a monomial denominator versus we're going to look at some binomial denominators, and that gets into a whole other can of worms. Yeah, I know. Yes. All right, so this becomes 3 root 5 over square root of 5 times square root of 5 is 5. That's kind of like we were talking about earlier, so it's 10. Can I simplify the 5 and 10 here? No, because this one's under a radical. Okay, so be very careful with that. So there's my final simplified. That was an easy one. Let's go a little bit harder. Always simplify first wherever you can. It will make your life a lot easier. Simplify. That was a dozer kick. I'm really sorry. I kicked the table. I did not. Multiply what? Yes. Notice there's more stuff in the bottom, but I only need to worry with that radical part, right? It's going to be a lot of simplification here, though. Excuse me. 12 breaks down to what? Root 7 times root 7 is just 7, of course. So I've got 6 square root 21 over 28. Easy peasy. Lemon squeezy. Oh, yes. Good catch. Now it's fully simplified. I would have lost points on my simplification there. Yeah. Simplify. Why? Hmm. Before you start rationalizing, did you simplify? You rationalized first or you simplified first? Did you? You multiplied by root 3a on top and bottom first? I would have definitely, before I started, I would have said, okay, this is the same thing as this. Agree or disagree? Which is 28a4 over 3. What's the square root of a to the 4th? 2 goes into 4 to a squared. So I get a squared times the square root of 28 over the square root of 3. Now I can rationalize a lot easier. Yes. Now, if you didn't do that first, that's okay. If you just went straight in and went, okay, boom, that works too. You just have more work. Um, 4 and 7, so 2 root 7. And now I'm going to go ahead and rationalize. So root 3, 2a squared root 21 over 3.
I got that, but I had an A inside.
But you still had the a on the bottom too? It should combine. No. All right, we haven't gotten to the hard stuff yet.
Sorry, there's actually 48.
Simplify. Am I dividing by a monomial? Yes. The denominator is a monomial. It is. Yes. All right. First of all, can I combine these as they sit? No. Why? They're not common radicals. They're not like radicals, right? They have the same root, but they don't have the same radicand. That number under there is not the same, right? So in order for that to happen, so there's several ways I could approach this problem. I could split this into 2 different fractions and add. I could simplify the 8 first, get them to be like radicals, then simplify the top, or I could just rationalize the denominator. Now, when I rationalize the denominator, understand what's happening here. This has got to bounce to everybody up top. Thank you. Right? So I get square root of 16 minus 2 over 2. Right? Which is 4 minus 2 over 2, which is 2 over 2, which is 1. Now, what happens if I have more than one thing in the denominator? So what if I'm dividing by a binomial denominator? Did we talk about conjugates when we were in complex numbers? We didn't? All right. I ate them. Go sit down. All right, here's what a conjugate is. A conjugate is when you have a binomial, okay? You change the sign in the middle only.
You have a microwave?
She did throw away the ball. The ball is still. Oh, I saw the ball. I remember. You lied to us all.
Wow, I'm telling you, Patrick, aka White Dad.
Okay.
She did throw away the ball.
I never said I threw it away.
Yes, you did. You did.
Okay, I also said I ate the keys. It's called.
Lying.
Okay. Conjugate means opposite sign of a binomial in the middle only. So in other words, if I had 4 plus the square root of 2, the conjugate of that, stop, Dozier, 4 minus square root of 2. Okay. I'm watching you today.
Literally getting my notes.
What happens when you multiply conjugates? Things start canceling out. What? Don't make me nervous. Okay. So if I did something like 4 plus root 2 times 4 minus root 2, watch what happens when I multiply this. The radicals are actually what's going to cancel out. Minus 4 square root of 2 plus 4 square root of 2. And what's root 2 times root 2? Root 4, which is 2, minus 2. Because I had to refresh you on what conjugates were before I told you what to do with the denominator. Yes. So here's what we're going to do. When you have a binomial denominator with a radical in there, okay, so you have a number plus a radical number. You're going to multiply the top and the bottom by the conjugate of the bottom. I could write numerator, denominator, whatever, but so just do top and bottom. Top and bottom, right? All right, let me show you an example and I'll be done. With imaginaries, complex numbers and imaginaries. We did complex conjugates, yes. That's not new. Yeah. 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 Take one past it and start zipping around. I'll show you. All right, here we go. Let's do one example and then I'll quit. Thank y'all so very much, jerks. Tell you what.
Liar.
Wasn't a lie.
You did lie. Just lie.
Okay,
And you even locked the doors.
okay, I apologize for lying, but I do not apologize for locking my cabinet. No. Oh. All right.
We're doing 38. Oh my gosh.
Exactly. All right, let me show you this one and I will be done. What is the conjugate? 2 minus 2 root 7. Top and bottom. Thank you, Dozier. I get myself in a foil situation, top and bottom. Gross. 6.
Minus 6, 7. Plus 6.
minus, what is square root of 7 times 2 square root of 7? Four minus 4 root 7 plus 4 root 7. Oh. What? No, minus 4, it's square root of 7 times square root of 7, which is 7. All right, what do I have? I have some like radicals up top. This is 14. 6 minus 14, negative 8. That's exactly right. Negative 6 root 7 plus 2 root 7 is negative 4 root 7. Over. 4 times 7 is 8 here. Middles cancel as they should. That is the definition of a conjugate. When you multiply conjugates, those middle terms cancel out. And now I have 4 and 28, which gives me dun, 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 dun. So, oh, right. That is not the final answer. Why is that not the final answer? You can simplify. That's exactly right. Remember, if everything can be divided, I hope all of you who have been on your phones the whole time know how to do this. You can simplify each one of these. Only the numbers outside the radical, right? So, negative 2. Actually, I'm going to divide by a negative and get rid of all these negatives. So, 2 plus root 7 over 6. No. You could break it up into two fractions. You could do 2/6 plus root 7 over 6 and then simplify that first one if you wanted to. But you don't have to.